Today's problem is ways to tile a floor. Difficulty is medium. Accuracy, look at this, 32%. It's pretty low. I mean, I there's no way to make sense of this, you know? I mean, if there's only three categories that you can put things in, easy, medium, hard, then obviously there's going to be a range of difficulty even within one rating. So if you say something is medium, and a lot of these are medium, some of them are going to be closer to easy, and some of them are going to be closer to hard. And I just saw one, what was that? A scheduling problem. I thought that was closer to hard. It had like a 70% accuracy. This one is much closer to easy, and it has 32% accuracy. You can't figure it out. So anyway, it's not really a valuable metric. Here's the problem. Given a floor of dimensions 2 by n and tiles of dimensions 2 by 1, the task is to find the number of ways the floor can be tiled. A tile can be placed horizontally as a 1 by 2 tile or vertically as a 2 by 1 tile. Two tiling arrangements are considered different if the placement of at least one tile differs. So, if n is 3 number of tiles, what can we do there? Well, we could put all of them in there vertically. We could put a couple in horizontally, and then that leaves one space to fill, and you can put the vertical tile either at the end or at the beginning. So total 3. What about n equals 4? Okay. Well, they go through 5 ways of tiling the floor with 4 tiles. Expected complexities: O of n, auxiliary space, O of 1. Okay. It's a dynamic programming problem. And the fact that it's O of 1 indicates that they don't want you to use like a full DP array, which would be O of n. That they want you to to maintain a smaller number of what do we want to call it? Well, actually, let me explain it again in a second. Company tags, Amazon topic tags, Fibonacci. They shouldn't have said that. That makes it too easy. Dynamic programming, recursion. Okay, recursion. This only goes up to 45. N can only go up to 45. Maybe it would work with recursion. I think you'd be better off converting the recursion to top-down dynamic programming, but we're going to do bottom-up dynamic programming. Fibonacci is also a dynamic programming problem. Now, if you do Fibonacci bottom up, then you say, okay, fib of, I guess you can do fib of 0. Fib of 0 is 1. Fib of 1 is 1. And then after that, fib of n is fib of n minus 1 plus fib of n minus 2. So you really don't need the whole array at any point. You just need to know the 2 previous values. So if you only need 2 values, no matter what n is, then that would make for constant auxiliary space. Okay. Now, one thing you can do here, if you're, unsure about what they mean by Fibonacci, is, let's bring this up. So n equals 3 was 3. I mean, we can, obviously n of 1 is 1. N of 2 is 2. You can put the tiles horizontally or vertically. They give us that n of 3 is 3. N of 4 is 5. Well, what about n of 5? What would the expected output there be? Probably 3 plus 5, right? Yeah, it's 8. Okay, so what about n equals 6? That's probably going to be 8 plus 5. Whoops, what happened? Why can't I change that? Hold on. Oh, I see, custom input. I'm sorry. 6. So that's 8 plus 5. 13. So it is, in fact, a Fibonacci sequence. I mean, you can keep going with this, but... So let's just do it like this. Let's do it like a Fibonacci sequence. If n is less than or equal to 2, return n. I think n has to be at least 1. Yeah, so 1, if n is 1, return 1. If n is 2, return 2. If n is greater than 2, then just set it up. You know, here's the answer for 1. Here's the answer for 2. Current, we'll set it to something. We can set it to 3 because, well, let's see. If I equals 4 and I equals 2 less than, yeah, okay. So this is only going to, I wonder if we have to set that, well, wait a minute. I equals 2. I is less than n. No, we still need something there to return the current. Okay, so the loop won't run, but we'll still return the current, which would be 3. After that, we'll say that at every step, the current value equals the previous value plus the value before the previous value. We'll scoot the other values down. So previous 2 equals previous, previous equals current, and then just keep looping. It's a Fibonacci sequence. So let's try running it. Yeah, it works, not surprisingly. That was easy, but that doesn't mean that you shouldn't like the video anyway. Let's see. Yeah, and you can subscribe to the channel, subscribe to notifications, and we'll see you next time.